Hello everyone, welcome back to Codemaster Java. Today we are diving into one of the classic LeetCode problem, contains duplicate. So if you are preparing for encoding interviews or just wants to improve your problem solving skills, then you have come to the right place. So let's break it down and figure out the most efficient way to solve this problem. So here is the statement for the contains duplicate. This is the easy level problem, and the problem statement is given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is a distinct. So let's look at an examples. The first one is nums array is equal to 1, 2, 3, 1. Here 1 is coming twice in this array, so the output should be true. 1, 2, 3, 4. Every element is a distinct, so output is false. Here the third example is 1, 1, 1, 3, 3, 4, 3, 2, 4, 2. Here 2, 4, and 1. These elements are repeating. So that's why the output is true. To solve this problem, we have three ways. The first approach is a brute force approach. The second approach is the headset approach. The third one is the sorting approach. In the brute force approach, we check each pair of element to see if they are the same. This has the complexity of big of n square, and it is not efficient for the large array. The second approach is the headset approach. In this one, we use the headset to track the scene elements as we iterate through the arrays, and we check if the element is already in the set. If it is, then we have found the duplicates. This approach has a time complexity of big O of n and a space complexity of big O of n. And the sorting approach, in this one, we sort the array, and after that we check the adjustment number, check adjustment elements for the duplicates. This has a time complexity of big O of n log n due to sorting, and space probability of big O of n if we sort in a place. Okay, so let's look all this approach one by one and try to solve our problem. Okay. So first one, we will try to solve it by the brute force approach. So in this one, we will look through every element twice to the nums dot length. Okay. This inner loop will start from j is equal to I plus 1, and it will we also look this look will be length of the array. Okay, here we will check if nums of I equal to nums of j. If we found the same element in this loop, then we found the duplicate. Okay, so we will return the true, or else return the false if we do not find duplicates. Okay, so let's run it with the local example. See, all the test cases are passed. Let's submit this problem. See, as I said earlier, that brute force approach will not is not efficient for the large arrays. As I said earlier, the brute force approach is not efficient for the large arrays. So we need to optimize it and to improve our complexity. So let's remove the unnecessary code here. Okay. Now we will try to solve this problem using the sorting approach. So first we will sort this array num, and we will check if uh, here we will start from the 1. so that we can check the adjustment numbers, and it will go till nums dot length I plus plus. Here we will check if nums of I is equal to nums of I minus 1. If it is the same, then we found our solution. We will return true. Otherwise, we will return false. Okay. So let's check out our code with the local test cases and see it's passing. Okay, passing for all these three examples. Okay. So let's submit it and see it's accepted. And it is taking 19 milliseconds to run our solution. Here, let's still optimize it with the using the hash set approach. And currently, you can see that it is taking 90 milliseconds to complete. Let's further optimize it. Okay, let's initialize the head of new hash set of input. Okay, and remove the extra accessible post which is not required. Now we will run the for each loop. Okay, and we will check. Yeah, we can use the hash sets add method, which syntax is it like hasset dot add, and it accepts the object element which is the type of the hasset, and it returns the this function returns the true if the element is not present in the hasset. Otherwise, it returns false if the element is already present in the hasset. As you all know that hasset contains only distinct value. It does not contain the duplicate values. So this is the best data structure to use in this problem. Okay. So let's use this one. Scene.add. Okay. Scene is our hasset. Scene.add our num. If it has this number, then it will return. Sorry. If this function will return true if the number is not present in the hasset. If it is present, it will return false. And to if it return false, then we'll note it out and we will return true because we found our duplicate. Otherwise, we will return false here. Okay. Okay. Got it. Let's run it out with the local test cases. Okay. All test cases are passed. Let's submit it out to check further test cases and just see the time complexity of this one. It's taking only 7 milliseconds to complete, and the space complexity also increased because the space complexity for this one is the big O of n, and the time complexity of this one is also big O of n. Okay, so that's it. That's it for the contains duplicate approach. And so we have walked through the context duplicate problem, explored all the different approaches, and implemented all the approaches with the brute force approach, with the sorting approach, and the hash set approach. So if you found this video helpful, please give it a thumbs up. Subscribe for more coding interviews. Subscribe for more coding contents. Hit the bell icon so you never miss an update. Thank you. Happy coding.